Well, this is not so crazy to think about. And today, I'm going to be covering some of the progress that has been happening in artificial intelligence. And I want to open with this question. I don't know if you have used or have seen GitHub Copilot, or you are using it today. And maybe one of the questions that you may be wondering is like how it learned JavaScript, when that happened. And not only this technology learned how to write JavaScript, but this past year, it has also learned how to refactor JavaScript. I don't know when you learn. I learned how to refactor code at the university. It wasn't even the first year. So now AIs are doing refactors, which is pretty exciting and maybe a little bit scary at the same time. All right. As you can see, I spend almost the same time creating my cover than the rest of the presentation. So my name is Gerard Sans. I'm not French. Everybody thinks that I'm French. I'm not French. I'm from Barcelona. And I'm a developer evangelist for web and cloud. And this is one picture that I took during the pandemic. I don't know what you did. I mean, some people started cooking. I started doing open swimming back in England, where I live. And this is 2 winters ago, and I was fully suited and with all the gear. I'm an international speaker, and as you can see, I've been all across the world. I've been doing this for a long time now, so I hope it helps delivering this talk to you in the best way. So what would happen if an AI could do your job? Have you thought about that? I mean, GitHub Copilot is only a little, the tip of the iceberg, isn't it? Another question is, okay, so when this may happen, do you think it's going to be in the next 20 years? In the next 10 years? Let's see what Elon Musk has to say about this topic. Earlier this year, of course, he tweeted this quote. And I mean, he tweets a lot of different things. But this one was saying that AI will take over humans in the next 5 years. Elon Musk was one of the founders of the company behind GitHub Copilot technology. So that's why it's relevant to this conversation. Maybe he knows something that we don't know. We'll see. So I will start with a small introduction, and I will cover a little bit of what artificial intelligence is, what have been the advancements, how is the inner workings, just enough to present Codex. So artificial intelligence covers all of the different technologies that try to imitate human intelligence. And this is a big endeavor. Part of artificial intelligence is machine learning. And machine learning is a special learning that doesn't need human intervention. So the machine or the different algorithm will train themselves look at the data, and without much human intervention will make progress and learn about a specific task. And that brings us to deep learning. And deep learning is mostly all about neural networks. And neural networks try to replicate the functioning of our brains in a very simple way. And that's where all the new developments and progress has happened. So let's talk a little bit about machine learning. Maybe you have seen some of the products that has been launched in the recent years. One of the main projects is the self-driving cars. This is a video from Tesla. And you can see a driver. They are not allowed to just leave the cars on their own. So there's just a driver in case of an emergency. And then you can see all the information that the system is tracking. So you can see there's some tracking of different vehicles in front of that car, and that's the information that is used to take the next turn. Another popular product is voice assistants. And I'm not sure if they have become very popular. I don't know if you use them. Usually, I ask people around, and they just use it for very specific use cases. They haven't gone much mainstream, I would say. People have them, and usually they change music. They play a Spotify playlist, something like that, but they didn't revolutionize much besides that. If you are also into gaming, you maybe have seen some developments there. There's a lot of AI working behind the scenes and making games more enjoyable. So these are some of the places where you can see AI today. And if we look specifically at neural networks, they will work in this way. And this is what this image is trying to convey. The neural network will go, for example, take this cat picture, will go through all of the different layers, and then through a trial and error process, will try to identify what is a cat or what is a dog. And depending on the pictures, we'll train on different aspects of that image that serve as an input. By doing this, it learns about the different characteristics, and of course, it's very much linked to the training data. So this is a little bit of an overview of what's happening behind the scenes. If we look at the future, looking at some of the work done by some experts in the area, we can define 3 different stages. And I'm going to look at this so you can see what may be happening in the future that you may not be aware. The first step of this AI revolution, which some experts call, is the cognitive revolution. And the cognitive revolution will be a stage where we use more and more AI assistants. Very similar to what we use today with GitHub Copilot. They are not going to replace the whole task, but they are going to help us to take some of this cognitive load so we can do more tasks or we can be more efficient. Next on this AI revolution is the robotics revolution. And I don't know if you are familiar with Ameca. So that will be a completely autonomous Ameca. Ameca right now cannot move. It very much resembles a human in the size and also in the facial expressions and also in language. You can talk to Ameca today, and it's pretty awesome, but it cannot move. It's completely static. So this second stage will be when we have some kind of android that is completely autonomous, but also can interact with you in a human-friendly way. The last stage is when we reach what is called the singularity. And this is when AIs surpass the capacity of humans. And this will be very much looking, if you are fans of Star Trek, this will look very much like the Data character. If we go back to the initial, when I started the talk, Elon Musk thinks that this could be 5 years away. I don't know if you have seen the announcements on Elon Musk on the robot that they are working on. It was a little bit of a disappointment if you saw the launch, but that's what they are pushing for. Okay, this is usually the reaction I get from people. I'm sorry to break it to you like that, but in order to try to convince you that maybe your jobs are in danger, I'm going to ask for a volunteer for a little test. Who is up to the task? Okay, nobody else? Oh, come on. No, you? You want to go? No, I'll take him. Thank you. So let's do this. Let me open this. This is a little experiment, and I just want you, if you come over. So I'm gonna try this. We're gonna do a little challenge, and this is gonna be our human representing all humanity.
Allegedly.
The legend. MC of this morning. And we also have this kind of a little game that I built using AI. So that's going to be representing AIs. So your task will be in the next few seconds, I will ask you, that's actually what we can see in blue, that's a button.
All right.
So you have few seconds, how much? 10, 15 seconds to try to click that button. If you achieve that, then humans win. If you don't achieve that, then AIs win. And maybe we are in the singularity already. So let's give him a round of applause and give him some confidence. You can do it. Come on.
I had never had such expectation just for me to click into a button, but if it is to save people, I can do that.
It's easy enough.
Well, I'm transgressing my beliefs since I'm touching a Mac, but still, for humanity, I will do so.
Oops. Okay.
Excuse me?
What's happening?
You ask me. Yeah. I am asking you.
Okay, it seems it's taking... Oh, what is that?
C'est les
Macs, the evil AI. Okay, come on, faster. Nothing. Okay, I think we can leave it there.
This is the hardest captcha I ever did. I'm human. I'm human. I swear.
Well, I think we have seen how AIs can beat a human on the stage. I mean, this is one thing that I wanted to prove today, that AIs are maybe more dangerous than you can think of. But thank you for this little demonstration.
I tried to click a button. Sorry, humanity.
This is just to show that I think sometimes we overestimate how capable we are as humans and what skills we have. Certainly, there will be some skills where a machine or an AI will be much, much better than a human. I mean, this is nothing new as developers. All right, so let's start by presenting GitHub Copilot. And this is a product that was released last year. And it was released in beta, so some people had to apply to use it. But now it's available for anyone just paying for a subscription. And this is how it looks. And the idea of GitHub Copilot is that it will assist you in your coding, your daily coding activities. And this is a little bit of the underlying architecture. I don't know if you have experience building Visual Code extensions, but this will look very much like that. So GitHub has developed this Copilot service that will store some context of what you are trying to achieve, and then it will propose some code. There will be some interactions, and that will send some request to OpenAI, and Codex will give back some code for you. And of course, the experience is quite nice, and that's basically the service that this product provides to you. The language support today, it covers all of these languages. So you can see there's TypeScript, JavaScript, Python, Ruby, Go, C#, and C++. Probably the most scary to me would be C++. I don't know what are you using, but that seems like quite a challenge. We are going to look into JavaScript, though. And if we look at JavaScript, the way it works is we just provide the signature of a function. And as you can see, GitHub Copilot has enough information just from the name of the function and also the arguments to create the logic for that function. As you can see, looking at the code, somehow GitHub Copilot knows about the APIs, the different APIs, and also knows what types these APIs return, some calculation. It knows also the libraries to do math operations. So it's quite impressive. I would say that the first time I saw this, I was quite surprised because there's nothing. I'm a software engineer, and there's no technology that was able to do this unless it was using some kind of template. But this is clearly not a template because you can write any text. It's free text, actually. So you could use any name for the function. Some people may think also that it's maybe using some kind of indexing. It's maybe a search into some database of code, but that would also not work. It will just provide always the same code as the answer, and this is not how GitHub Copilot works either. So we are going to look into how this is working behind the scenes. Another thing that you can do is you can start providing some code, and GitHub Copilot will find a pattern. So this is the declaration of some variables, and GitHub Copilot was smart enough to pick up on that and create the sequence, no? What goes next. Similarly, when you use Microsoft spreadsheets, it will just know that you want to fill in with more code, and it will just generate those new lines of code. Another way of using GitHub Copilot is writing a free text command, and it will use that information as commands to write the function. So this is a little bit different of what we have seen before. Before we use the signature of the function to create its content, but now it's using a free text as a command. What we can see here as well is that somehow GitHub Copilot not only knows about JavaScript, but it knows also about the DOM. It also knows about styling. Like, what's going on? I thought it was JavaScript, but now it's also CSS and the DOM and the browser. So it knows a little bit more than that. How is that even possible? There's another feature that is quite interesting, which is navigating between different options. So imagine GitHub Copilot finds several options. It will show you a list of these options, and you can navigate and pick the one that you like. This will be more or less like a Stack Overflow on steroids. So you can see some of the code snippets that apply for that context, and then you can pick the one that you believe will work best. This is very exciting because actually there has been studies that show that using GitHub Copilot gives you a boost on performance about 10%. It's not going to do your job, but it's going to make you much more efficient. So this is how people feel when they use these tools, and this is more or less the first section that I cover. So I hope you are enjoying it. I'm also using a lot of cats pictures. I don't know if these are popular here in France. Maybe the next time I will use a massive elephant to make it context dependent. So now I'm going to cover OpenAI. So OpenAI is the company that built this technology, and I think it's quite interesting to know a little bit of the history behind its creation. So these are the co-founders. We have seen Elon Musk at the beginning. There's also Sam Altman and Greg Brockman. They created OpenAI, and funny enough, they state as their mission that they want to build a safe artificial general intelligence that benefits all humanity. And when you read about these statements or mission statements, it feels a little bit strange. Like, what are they talking about? Benefiting all humanity. It seems like maybe they are overreaching. And also thinking about this AGI that resembles very much the singularity and the character data in Star Trek. So they are kind of mentioning that on their mission statement. Maybe a marketing stunt. We don't know. They created the company in 2015, so that's not long ago, and it raised quite a lot of money. It was only in 2018 that they created the first generative pre-trained transformer. Transformer is actually the architecture used behind, so that's what has spurred all of this progress. If you want to look into it, that's what sits behind all of these new products, the transformer. And at this moment, the models were very small. Even for today's standards, that's a very small model. It's 117 million parameters, and the parameters give you an idea of the size, how big the model is and how capable it is in order to generate language and later on code. In 2020, they opened an API, so anyone can access GPT-3 and use the services. And for GPT-3, at this time, it was the largest. Even today, is one of the largest models. And this is a 175 billion with capital B now. Before it was millions, now it's billions. And that's a significant increase on the size. It was only last year, if you believe it or not, that GitHub Copilot was released and also Codex with it. And Codex is a little bit smaller. This is just only 12 billion parameters. But one thing that you need to take into account is that GPT-3 is exactly the model that they released 2 years ago, but now trained only with code. So it has all the capabilities of GPT-3 plus knowing how to code. Some people think that is a separate model. It's not. It's GPT-3 plus the coding. In 2022, there has been few new releases, quite exciting. They added what they call insert and edit. These are, of course, AI experts. They are not software engineers, so that will be for us refactoring or iterating over code. They released this feature for all of the different models, so you can use these for text generation, code generation, and also image generation. So this applies to all of the products across the board for OpenAI. They also released DALL-E 2, which is probably the most popular. You may have seen images of generated by DALL-E. There was a talk yesterday. Very exciting developments there. They just released last September Whisper, which if you have been using similar technologies, this is for speech recognition, and it will take a recording and it will give you a transcript of that recording. Before that, you would have to use a paid service. So having this technology open source is a big improvement for all of the applications in that space. There's also good news. DALL-E 2 now is open for general public, so anyone can just log in and generate these fantastic images. So this is a little bit of an update of what's been going on in OpenAI. Just to show you a little bit of a comparison of the different models and the progress that has happened in the last years, you can see the GPT-1 model was almost, you cannot even see it. This is a logarithmic scale. GPT-2, it's a little bit bigger, but you can see that the progress has been fantastic. There's also some other models created by other companies that I just put here. I stopped this graphic in 2021 and there's new models today. And you can see also Codex is quite small compared with GPT-3. So the most capable model today is GPT-3, and when we use Codex, we are just using the coding generation capabilities of it. Okay, so these are all of the different services. Just to give you an overview, there's GPT-3 to generate text, Codex to generate code, which is still in beta access, and DALL-E to generate images. All right, just a little break before we go to the next section. And I want to focus in Codex, but there's no way I can go into Codex without covering GPT-3. And this is where all the magic happens. So how GPT-3 works? Let's see it in action. And we can also see the grumpy cat. I use the grumpy cat just to make it a little bit more lighter. I'm not sure if you are up for the talk because of the after party yesterday. So let's see if that is easy enough for you. He will be interjecting some comments along the slides. So this is a free text I just wrote on the interface. The day started as any other day. And a lot of the people is using GPT-3 just to write free text like for a novel. And this would be something that you could use GPT-3 for. And that's called the prompt. So that's the input for the model. And we can use some what is called hyperparameters to change how the model reacts. We are going to leave the defaults for now, and that will be the completion. So actually, that will work as an autocomplete. It will generate the next word, and then the next word, the next word, until we get a full sentence. And we can stop there, and this will look something like this. The day started as any other day with a couple of hours of intense work before lunch. So the text is, I would say, indistinguishable from a human. It makes sense, it's grammatically correct, and this is what people is excited about. Now we have models that can generate text for different purposes. So yeah, that's kind of the intro. Not very excited, our friend. Some of the things that people discover, they open this to all users when they open the OpenAI API, and people started to try different things. And one thing that they discover is that they could create a pattern, like in the form of a conversation, like question and answer, and somehow GPT-3 was capable of answering back. And wait for the next question. So that was something unexpected. And there has been a lot of these patterns uncovered, and people are just finding more and more as they use GPT-3. And this one is a little bit like perplexing, like, okay, so this is the answer, the actual answer. So now what's going on here? It's not free text. It's also answering with a proper answer, with a fact. But then, of course, if you keep the conversation, you realize that the data coming back may not be factual. So this requires some experience. This is something that you need to get used to when you use these models. There's a few things to take into account. And yeah, that absolutely is not right. And some of the things that people have discovered over the last 2 years is that some of the answers are biased, and this is because of the training data. Another thing that will happen with GPT-3 and also Codex is that it can do what some experts call hallucinations. And these are non-factual information. And there's also some other problems like inaccuracy. You can maybe try to do a mathematical operation. It will come back with a wrong answer. So these are some things to take into account. One thing you need to take in consideration is that this is a very recent technology, and it may show some information that is not accurate. So what are the different stages that these models go through? I'm just going to go over the main ones. There's a design stage. There's also a training stage, which is where GPT-3 learns all the different skills. And then there's the prediction stage, which is when we use it in our playgrounds or when we use the API. So let's look at some of the details of GPT-3. That was released in June 2020. And it was trained using all of these data sources. And I'm going to cover this in the next slide, so I'm going to move into some other information. We have covered the 175 billion parameters. Another details are that it's using 96 layers and 12,288 dimensions. And the dimensions are all of the different properties that the model is able to deal with at the same time, which is quite impressive. The data that was trained GPT-3 is not a lot of data, it's just half a terabyte. So you can imagine that these models, if they are trained with even more data, they can be even much better. So talking about the training data set, one of the main, if you look at the percentages, one of the main training data was from a common crawl. A common crawl is just going into the internet and downloading all of the assets from a website. That will be all of the raw files. And the Common Crawl is a project that will do that regularly all over the internet. And these are usually the top websites, so that includes anything that you can imagine, from commercial websites to marketing to anything you imagine, blog posts, etc. Another data source that is very important is the book 1 and 2 corpus. These are few hundreds of years of public books of all different styles. Then we have web text 2, which is information from Reddit, if you believe it, and also Wikipedia, which is the smaller. So anything that is contained in these data sources, GPT-3 will have knowledge about them. So how the training phase works? Well, if we go into the steps that happens for GPT-3, it will take an article for Wikipedia, and we can see here it's an article from Christopher Columbus, and we can take one sentence, and we'll take the first word, and GPT-3 will do this game where it's trying to guess the next word, like an autocomplete. And here we can see the input, so we know that it's not is, it's Columbus, so that failed. Then we read the next word, it tries to guess, it's proposing was, so Christopher Columbus was. That's not the next word is discovered. So that's going to be a failure. Every time that GPT-3 tries one of these options, it will adjust internally that trial and error training, and it will improve the performance of the model. This is very computing intensive, and it's very expensive. That's why we can only use OpenAI models, and it's very difficult to replicate that kind of training in-house. Now we can see that GPT-3 is proposing America finally, and that's a hit, so that's going to be adjusting as a success. And now we are getting more success as we go through that sentence. That also is correct, and also the dot is correct. So this is very much all of the training. Now you have learned how GPT-3 learn all of these different skills. So what is happening inside this model is that we are creating what is called a hyperdimensional graph, and it's going to use all of these different words and concepts and create these different relations. Depending on the training data set, different words will have more or less importance, and it will create the relations that will make then the next word prediction more valuable. I'm going to use the example of Christopher Columbus, and all of these arrows, as they repeat more and more in the training data, they will strengthen, like in the brain, they will strengthen these relations, and the number of these relations will go up to 12,288. 88. So that's how it works. If we look at a smaller model, this is just 10,000 entry points, and we look for, if we look for a specific word, we can see that here, let's take just 5. We can see how these models work. So I'm just going to isolate the results. And you can see how these models propose the next word. So here we can see that there's Christopher. Then we see some other information. We see Robert. We see some other options. And when we look at these generations, this is what gives the information to GPT-3 to write the next word. So this is how it actually looks. So what can we do with them? One thing we can do is we can understand more than 100 languages. So it not only speaks English, but it can also understand all of these languages, of course. It understands French, and it can also be used in all these different use cases. So it can be used for writing. It can be used as in a conversation, coding tools. Somehow they realized that it could write JavaScript without having any specific training. This is because it was using the common crawl, and you know that most of the content in the internet is basically HTML and JavaScript. So that's how it learned. And then we can also do translations. This is some of the fancy use cases. So it not only learns the language, but it can also translate from any of the 100 languages between them. It can also automate summaries, which is another exciting feature, and it can follow instructions. There's a lot in GPT-3. I would need a whole day to show you all of the capabilities, but we are going to move into Codex. Codex is the effort from OpenAI when they discovered that they could generate JavaScript to improve that task. And they decided to partner with Microsoft, and they go ahead and took a snapshot of GitHub in May 2020, and that includes 54 million public repositories. This is basically everything, and they created Codex, which will be the model specialized in code. This is not that much data. When they sanitized it, it was only 159 gigabytes compared to the ½ terabyte of GPT-3. Codex is much more capable than GitHub Copilot. It also covers other languages like Rust, Swift, PHP. It also understands SQL and shell commands. Anything that is in GitHub, it can generate. So how it looks? Well, we can use the same approach that we have seen before. We can just write a command that will trigger JavaScript. Of course, it understands that / is JavaScript, and it will generate what is most probable as the next word, as we have seen with GPT-3, and it will come back with the answer. So that was impressive, and nobody knows. The neural network learns from the training data, and that's what it generates. Another thing that is quite impressive is that you can just describe your schema. It's not even a full schema definition, and it will generate a query. And you can ask for any queries, and they will be valid queries. And this is just one example. This is not very exciting if you have been using data access technologies, but if you are a non-developer, this is really exciting. And of course, anything else, anything that you can imagine in those 54 million projects, it's of knowledge of Codex. So it can write, following your instructions, a regular expression. Why not? And This year, they released 2 more modes. So that's the completion, when you generate the next words and code. But now you can also insert and edit, which is really, really crazy. And I'm going to use, this is more like the to-do app of Codex. And I don't know if you are familiar with the Fibonacci series. It starts with 0 and 1, and then it takes these 2 base cases to calculate the next value. So it's going to add 0 and 1, it will create 1. Then the next is 1 plus 1, it will be 2. 1 plus 2, it will be 3, and so on and so forth. So if we use the completion feature, we just write what we want. And I'm just queuing. If you know Markdown, this is a way to tell Markdown that I'm going to write some code. And this is what Codex finds. It needs to identify a pattern. So it sees that this is the pattern for Markdown for a code snippet. So it will write the function. Now, if you realize I'm also using TypeScript, somehow, of course, it learned TypeScript. And these are the 2 cases. So for n equals 0, it will return 0. N equals 1, it will return 1. And then it will return the sum of these 2 previous values. Another thing that I can do is, now that I know the function, I can use the insert feature, just released this year, give it to Codex, and somehow it will generate the code that is missing. That also works for your code, and this is what is using GitHub Copilot behind the scenes. Of course, you can imagine this being used for documenting the code, creating new functions, and code refactors. Another thing that we can do is tell Codex to iterate over a code. So I can take the last function and tell Codex to improve the performance. And if you know a little bit of coding, depending on your experience, you know that the Fibonacci is a good example to use memoization. So we do an intermediate calculation, we store it, and then we use that value in the form of a catch. So that's exactly what Codex writes here. It creates a catch with the base cases, and then depending on the value of the Fibonacci sequence number, it will use the catch, or it will do the calculation. That will make this code much more efficient, and this is exactly what Codex did. So now, we can repeat this process, and we can iterate as many times as we like, which is basically everything that we do as developers. So what can it do? Actually, it can do many things. It can document code, it can do code refactors, it can insert code. You can also ask it things in context. It will come back with answers. As we know, it can do question and answer. So you can ask, for example, what were the major changes between 2 versions of a library? It will tell you. It can also translate between languages, so you can translate code in JavaScript to Python, which it didn't exist before. I mean, I don't know if there's any technology that can do that. And it can also follow steps. You can write a list of steps, and it will follow the steps and code as it goes. GitHub Copilot is only showing some of the features that Codex is able to do. I can tell you that. So one of the nice features that I found, there's many, but one of them is what I call advanced data manipulation, which is taking a free text, you give it some instructions, like, okay, from this free text, I gathered this information from TomTom yesterday. I just want to create a JSON file which is JSON-L, which is creating a new line per entry. And I can tell, like, use these properties. It will do exactly that. The postcode actually was not in the data, so it just added the postcode. I hope it's the right postcode. It is, I check it. Then you can iterate. So you can say, like, oh, rewrite as an array with only the city. So it will just do that. And now maybe you will be scared. I'm going to use XML. And it will transform the data. I don't know if you do data science, but I mean, if you're doing data science or data manipulation, this is like insane. These are usually the faces I get. So live demo time. And I'm going to move now to the demo environment. And I want to show you a few things. We've seen that. So probably I want to show you one a scenario that I used. Let me see if I can find it. Follow instructions. No. Animations. Detect browser. These are few of the examples. Weather in Nantes. Okay. Code review. Oh, it can do reviews of pull requests. To-do app, of course. You can ask it to write a full to-do app using React and Tailwind. You can transform between promises to RxJS. Okay. Some background. Let's see this one. Okay. So these are some questions that I ask. What are the main differences between major RxJS versions from 4 to 7 and what years they were released? And this is the answer. The main differences between major RxJS versions from 4 to 7 are RxJS 4 was released in 2016, etc., etc. So which one introduced major changes? The most major changes occurred between RxJS 4 and RxJS 5 with the introduction of lettable operators, which allowed for greater tree shaking capabilities and smaller bundle sizes. So you basically have a body that can tell you anything. Okay, so now I want to show you a demo. We have not a lot of time, but I want to show you how you could maybe in the future face no-code scenarios. And I'm just going to go ahead and create this very quickly. And I'm just going to go and provide the instructions. So basically, the way it works is I provide some instructions, and Codex will generate the code for it. So that's the first. I'm just creating a container using Flex. So it knows different CSS providers. Now what I want to do is go ahead and create a login page, and it will just create all of that for me. And I want to do it in Tailwind because it's fancy. And it will just spit the code for me. And this is the actual output. Oops, sorry. So that's one of the main usages that I see, this technology being used, and it's no code or low code. Now what I want to do is add some interaction. So I want to add an animation that will shake the form if I don't have the information. Okay. Oh, it seems it's missing the actual animation. It's the next step. So let me add the animation. And this could be a task you receive when you get to the office. All right, so let's try it. So now I have two empty fields, and it adds an animation if these input fields are empty. Another thing I can do is I want to show a red border when that happens. So I'm just going to ask to add that. And if I try it again, I can see the border is being added. Another thing I want to do is now I want to add an animation, a loading indicator that takes 5 seconds to navigate if I provide the user information. So I'm going to do that. It takes a little bit of time. And you're going to see the result now. All right. And here, I'm going to repeat that last step. It didn't work. Okay. So you can also change this. Just let me run the last step. But this is very much what you could be using in one of these tools. Let's see if this works, otherwise I'll move on. But you can see that you can introduce more features and iterate on what you are building, and then move this to your environment. Let's see how that works. Of course, the demo is not going to work. Okay, let's see for the next bit. Okay. And okay. Okay. Well, the animation didn't work. No worries. But you can see how you may be looking at this building using no code. So the future, I see that there will be new solutions, and I identified these two, no code and low code. These are some products that you can use today. Some they will be fully AI generated, some will be just AI assistants. And these are some of the different pricings for OpenAI. So these are not too expensive. The most expensive is DaVinci, but the other ones are quite usable. And most of the code that you use in Codex is for free if you are using the playground. So that's something that you can start playing today. So that's all. What would you like to build using this technology? I think we have found a new way of building and coding using AI. And I think the opportunities are massive. If you want to use it, take a look at OpenAI Playground. You just need to sign up and start using it. Thanks for listening. It was a pleasure for me.